Hi there, everybody. This is Mr. Bear, and I'm going to talk to you about Unit 2.2, which is solving absolute value equations. Before I get started, I just want to let you know that I am going to run through this relatively quickly, as I only have 15 minutes to make the video. So please, 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 if you need to pause the video to help you catch up in your writing, please make sure that you do that. Otherwise, you should find this lesson to be pretty straightforward. I will, of course, review this concept with you when we get back. All right, so let's get to it. So, absolute value. When we talk about absolute value, we're talking about the distance a number is from 0 on the number line. Okay, so how far away from 0 does a number exist? Okay. We also should know that an equation is a statement that values two mathematical expressions equal. And when you solve or find the solution, you are finding the value or values. So I'll put S in parentheses because sometimes it might be more than one that make the equation or expression true. Okay, so now that we got some vocab out of the way, let's go through the steps to solving an absolute value equation. First of all, absolute value is something that looks like this, okay? These little vertical bars here tell you that you have absolute value of something. Okay, now our first goal is to be able to isolate that absolute value, okay? Which means get it by itself. So in this case, I have that stuff in the x plus 4 and the absolute value, but I have that plus 2. So I'm going to subtract 2 from both sides. So I'm going to do that first. Okay, since our absolute value is equal to a positive number, we are able to solve this, okay? So we're going to rewrite as two equations without the absolute value sign. One with a positive and one with a negative. So let me explain what that looks like, okay? So this x plus 4 equals 5, I'm going to write this in two ways. So x plus 4 equals positive 5, just like you would normally think. But then I also need to consider the fact that x plus 4 could be on the other side of 0 over at negative 5. So I'm going to have x plus 4 equals negative 5. And I'm going to solve both of those super easy equations for x by subtracting 4 on both sides, and I get x equals 1. And on this one, I get x equals negative 9. Okay, so that was me solving each equation. And our solutions are x equals 1 and x equals negative 9. And one thing that I always encourage students to do is like check. So if I plug in this 1 for x here, 1 plus 4 is 5. The absolute value of 5 is 5. Add 2 more and you do get 7, so that works. If I plug in negative 9 for that same x, negative 9 plus 4 is negative 5. Once you take the absolute value of negative 5, you get 5. And then 5 plus 2 makes 7. So both of those do work, so we have now solved this equation. Okay. Once we isolate the absolute value equation, beware of negative values. Okay. Absolute values can never equal negative numbers. Okay. So let's say I had this equation. Again, we see the x plus 4 and the absolute value. So that piece we're trying to get by itself. So we have to do that first before we can discuss what the note was there. So take away the 2. And we get absolute value of x plus 4 equals a negative 9. This is impossible because absolute value of nothing gives you a negative number. So we would say there's no solution here. Okay? And that's as far as we would go. So please do not set up your two equations if you see this happen. Okay? Or I guess more specifically, there we go. More specifically, it's that negative there. Okay, when you see that happen, no solution. But make sure you get the absolute value part by itself. Okay, so with that said, excuse me, I'm going to go ahead and do a few examples. All right, so follow along here. We've got 6 examples, I believe. Yep, 6 examples. These are all on your note sheet. I'm just going to model various examples so that you can see what happens in various situations. First thing I really encourage you to do is somehow indicate your absolute value, okay? That way you know what you got to get by itself. If you don't do this part, then you're going to get the problem wrong 9 times out of 10, okay? Sometimes I tell students to take their pencil or pen and circle it. Sometimes if you have a highlighter, I tell you to get your highlighter. Get that absolute value part somehow indicated so that you know what you need to get by itself first, okay? And if you still have anything on one side of the equal sign that that is not with that absolute value, then you need to move that to the other side, okay? I'm going to draw these little lines down the equal sign to kind of help me do that. So on the first one, I'm going to subtract this 8 from both sides. And I get absolute value of x plus 4 equals a negative 1. And once you see that negative right there, you can stop and say no solution. Okay? Now the next one, I don't have to get the absolute value by itself because it already is by itself. So let me erase that line I drew. Since it's equal to a positive number, we can make our two equations. So 3x plus 2 will equal 7. That's the equation that gets you on the right side of the number line. And then we also have 3x plus 2 equals negative 7. Okay? Remember, now that I'm removing the absolute value bars, it's okay to just have a normal equation equal a negative. Okay? So these are two steppers. So I'm going to do subtract 2 from both sides. I get 3x equals 5. Divide by 3. And this is not a whole number, so it's okay to leave your answer as fraction like this. Okay? If we do the other one, I subtract 2 on both sides again. I get 3x equals negative 9. Divide by 3, and this time we get an integer, negative 3. That's how you do it. On the next one, I need to subtract 8 on both sides, and when I do that, I get absolute value of 2x plus 4 equals negative 7. At this point, I hope you are looking and saying, oh wait, I have an absolute value equal to a negative, and that is not allowed. So once again, no solution. Okay? All right, for the next one, I've got that minus 2 that is not a part of the absolute value, so I need to add 2 to get that to the other side. And I get absolute value of 2x minus 4 equals 5. And since that absolute value equals a positive number, we are allowed to write our two equations. So 2x minus 4 is equal to positive 5. That's 5 on the right side of the 0. And then 2x minus 4 equals negative 5. That would be the value of x that makes that true on the left side. Adding 4 to both sides, I get 2x equals 9. Divide by 2. And when I do that, I can either write 4.5 if you put that in on a calculator, or you are certainly welcome to leave your answer as 9 over 2. All right. Solving the other one here, I'm going to get 2x equals negative 1. Divide by 2. And for this one, You can either leave it as a fraction or you can get the decimal. I don't care which way you put that. Okay. And it's okay if you're not getting whole numbers and integers on these. All right, if you look at these last two, on these last two, you'll notice that our absolute values have something in front of them as well as something after them. So we need to start by, if you think of this right here as just like a big old U, this is the same as saying like 5U plus 8 equals 23. When you solve an equation like that, you know you would subtract 8 from both sides first. Okay, and then you would, after you do that, you would then divide by that 5. So I want you to think about that as you solve this equation. Okay, probably should have mentioned that it's okay if you didn't write that out. So we're going to start by doing the minus 8, and we get 5 times the absolute value of 8 minus 2x equals 15. Then we have to divide by this 5, okay? Dividing by that 5 allows you to get that absolute value by itself, okay? Absolute value bars are not parentheses. We do not distribute in them, okay? We are going to divide by the number in front of the absolute value bar. And so now we get absolute value of 8 minus 2x equals 3. And since that is equal to a positive number, we are able to set these equations up. So 8 minus 2x equals 3, and 8 minus 2x equals negative 3. Okay, solving this out, you already know, I hope. 3 minus 8 is negative 5. Divide both sides by that negative 2 in front of the x. Since we're dividing a negative and a negative, you would get 2.5, or you could leave your answer as 5 over 2. For this one here, same idea. Negative 2x equals negative 11. Divide both sides by negative 2. 2 goes into 11 5 times, and then half of another one, so 5.5. And it's positive because we divided a negative by a negative. Okay, last one, and then this should be enough for you to be able to work on your IP. All right, so on this one, notice I highlighted the absolute value of 8 minus 5x. I need to add this 10 to both sides. Okay. So notice this negative in front of the absolute value, so we still bring it down. And just like if we ever had a number in front of a letter, we would treat that as a negative 1. So what I'm going to do in red is I'm going to pretend that there's a little negative 1 in front of that. Now, absolute value is not by itself yet, so please don't look at this and say, oh, that equals a negative, I'm done. We have to divide by that negative 1. And when we divide by that negative 1, you will then see that this equation can be solved. So now we're going to write our two equations. So we have 8 minus 5x equals positive 9, and 8 minus 5x equals negative 9. Solving them both for x, negative 5x equals 1, divide by negative 5, and you know what, I'm leaving this as a fraction. I do not feel like finding the decimal for that, and plus I don't have to. All right, other equation, negative 5x equals negative 17, divide by negative 5, and I have a negative divided by negative, so this will just be 17/5. If you want to find the decimal for that, that is okay. But this is how you would do the lesson. All right, so I hope this made sense enough to where you can work on your IP. Feel free to work with a partner as you are working through this IP so that way you can ask each other questions, compare answers. Don't forget to check the partial key on Google Classroom.